one application. So don't worry, hatujafanya mifano, tutafanya baada ya kujifunza na efficiency. Hapa tutacombine yote hapo mbele. Baada ya hichi kipengele tutaona mifano ya kule power, energy plus is output na efficiency. So the efficiency is the ratio of power output to power input. What is resistance matching? At the end of this explanation, you should be able to define resistance matching. So going back to our objective, efficiency is equal to the power output over power input. Power output is the all the power that is used by electrical components in the circuit, but power input is what the cells, kama ni accumulator, ile power ambayo inaingia kwenye circuit inakuwa produced na all active components kwenye circuit. So assuming that we have our circuit kama hivi, that we have our cell having internal resistance R1 and we have an external resistor R2, probably, obviously, the power output will be the power that is consumed by the resistor and the wires, labda kama wires na zenye zina resistance, that will be power output. Power input will be the power provided by the cells. Kwa nini nilisema zile formula inabidi tuwe makini? Kwa sababu when we are speaking of, like I said, when we are dealing with cells, we define power as product of V times I, where V is the EMF of the battery. But when we are speaking of power output, we now mean I, R2 and all other resistors that are using, all other passive components that are using the power. So we know efficiency is equal to power output. For this case, power output is equal to the I squared R. Sorry, this was I squared R, and where R, this is the effective resistance for all passive components in the circuit. The power input is equal to the total power that the cell delivers to the circuit. I said when I deal with cells, we use the VI, where V is the EMF for this case, EI. Therefore, we know that V is equal to IR. So in this part equation, if you take one I from here, you multiply with R, you form voltage V over E. Then here you will remain with 1I, and here down we have 1I, so they can cancel and you remain with V over E. So the efficient is given by the efficiency V over E. But we know that our V was IR, and our E, you remember I said EMF is equal to I times R plus R. Maybe I should tell you why the EMF is given by this formula, R plus R. This is actually because I said the EMF is equal to the total power that this battery can give when it is not connected to any cell. That means if this circuit has a number of passive components, all the power that is used by all the passive components, if you take all that power, assuming that all the power that has been produced by the battery is going to be used by all the passive components in the circuit. So if you take the power consumed by each passive component, you sum them up, and plus the ones, all the energy that is lost as heat and etc, all that when you put it together is equal to the EMF. That's why here we have IR plus R. We assume that we have the internal resistance of a battery and the external resistors, whereby the external resistors can either be the wires themselves or any other connected external resistor or device that has resistance externally to the battery. So the power that is lost as heat, that's why we consider by the battery itself due to the internal resistance and the external resistance. When you sum them up together, you get the total energy delivered E. So here we have I times R for the external resistance and I times R for the internal resistance. So you get the whole total power that this E can give. You remember I said I times R is the terminal potential difference. I hope you can remember. So E is equal to I R plus R. So we can cancel I, and I will remain with the ratio of resistors that we have R divided by R plus the small r internal resistance. So we can see that if this resistance is very far greater than the internal resistance, then this R can be neglected in such a way that R and R will cancel and efficiency will be approaching 1 or 100%. So that means if your battery, the application of this means the battery yako ikiwa na internal resistance kubwa, efficiency yake itakuwa kubwa, kwa sababu not much energy will be spent as heat. Ndio maana sometimes batteries zina heat kwa sababu kutokana na formula yetu ya power is equal to I square R, inaanzia kwenye battery yenyewe. Kama ina internal resistance itakuwa ina lose this amount of heat. So tukipunguza internal resistance, it means kutakuwa hamna loss ya heat. Kwa most of the power itakuwa inatumika katika kwenda kwenye components ambazo tunahitaji kwenye circuit, na ndio efficiency tunachomaanisha kwamba power unayotengeneza inaenda kutumika yote. So the more you decrease the resistance, the higher the efficiency. So battery yako ikiwa na internal resistance kubwa inakuwa less efficient kuliko na battery ambayo ina internal resistance ndogo. But also we can see when R is equal to R, when the internal resistance is equal to the external resistance, it means your energy is used 50-50. That half will be used to be lost as heat by your battery, and half will go to the required devices to be used. That's why the efficiency will be 50%. It's because 50 of it is going to be lost as heat, 50 of it is going to be used as intended, kama ilivyotakiwa, ndio maana efficiency inakuwa 50%. But consider that if suppose power is equal to R, power output E squared, okay, R E squared, we use the other formula of P is equal to V squared over R. But again, from our formula of losing heat in the resistors of P is equal to I square times R, we can convert this I here. We can find the value of I, but from here I is equal to E divided by R plus R, so that in the square of I we substitute and we put this value here. So we have E square R plus R squared. So our interest here is to find the situation whereby power will be maximized in the circuit. From the calculus basis, tukidifferentiate our derivative tukaequate is equal to 0, the value of R ambayo tunapata, the value of R ambayo tungepata, hiyo value of R internal resistor ndio ingekuwa inatuambia maximum yetu ni ipi. So it's the maximum power will be given at a point where the first derivative of this equation is equated equal to 0. Ukitafuta value R unapata maximum. I think you can remember from your knowledge of differentiation. But on the other hand, we can use another approach, that if E squared R over R plus R squared is equal to, you just expand the denominator, but okay, expand inakuwa R squared plus 2R plus R squared is equal to that. So we can factorize more this. For instance, when we write this value here, 4R minus 2R is equal to plus 2R. So we haven't changed the meaning there. So but hii ni identity fulani kwenye algebra, sawa, ambayo hiyo identity ukiandika vizuri, ukirudisha kwenye condensed form ni sawa na hii hapa. So R minus R squared ndio unapata hii value hapa. So unaitoa hii 4R nje ili ubaki na hii condense irudi kwenye hii form huko. So inakuwa R minus R squared plus 4R. Umeona? Kwa E squared, kama ukiamua kucancel hii R, kwa ukicancel R it means you divide na R hapa, ndio inakuwa hii hapa. So nabaki na E squared over R minus R squared over R plus 4R. Sawa, Yeah. If you want to maximize the value of power, the denominator, mathematically the denominator has to be low and the numerator has to be high if you want this to be maximized. So if you want to concentrate on minimizing this denominator, if you want to concentrate in minimizing this denominator, so we have to make sure it doesn't cross beyond 0, because if this value is negative itakuwa inatoa hapa na kuifanya hii denominator iwe ndogo zaidi. So we have to make sure this is less than 0. So if we assume that r minus r squared over r should be equal to 0, this should be the limit, then this time this itakuwa 0. So r minus r, okay, squared is equal to 0. Tafuta square root, tunakuja kupata r minus r is equal to 0. Therefore r is equal to r. That's the point where we maximize your, that's the limit where you maximize your power. That power will be maximum that way. That's why when r is equal to r, it is found when the external resistor is equal to the internal resistance. The efficiency is half 50%, but the power is usually the maximum. The power that will be yielded in such an instance will be maximized. And so for such cases where the internal resistance is equal to the external resistance, that's what we call resistance matching. So you can define resistance matching as a situation whereby in a circuit the power is maximized, power in the circuit is maximized. As such, it is a case where the external resistance is equal to the internal resistance. So I said that resistance matching is the situation in a circuit whereby the power is maximized in such that the external resistance in the circuit is equal to the internal resistance. So for such cases, that's when we'll get maximum power in our circuit, when the external resistance is equal to the internal resistance. So that's what we call resistance matching.